For this related rates problem, we want to follow this. It's like a 5-step process is typically how you'll see it. It's how I do these. So the first thing we want to do here is set up the equation that relates to these distances that are discussed. Now, no distances are given, but there is this relationship between two cars. One's driving this way, one's driving this way. Due east, I'll call this X. Car X going due east, car Y driving due south. Assume that the angle between them is a right angle. And then we'll have the distance between the two cars at any given moment. I'll call that distance Z. Okay, so I think it's pretty straightforward. There's no angle mentioned, so it's pretty straightforward that we're working with this relationship between our three unknowns, Pythagorean theorem. And step 2, I like to state what the given rate is. And I like to translate that to a derivative. In this case, there's actually two given rates. This car that's going due east, car X, the rate at which it's changing would be the derivative of X with respect to time. And that guy's going 60. And then we have the guy that's going south, dy dt, the rate at which y is changing, and that would be 50. Okay, and then my step 3 is going to be what I want to find, right? And the rate at which the distance between them is changing, translation to math, dz dt. And then I like to kind of say, what else is given? Well, nothing else is given. However, we're definitely going to need some more distances or some more information. That is, if I try and predict what's going to happen when I take the derivative with respect to time of this equation, I should have some rates, dx dt, dy dt, dz dt, but also x, y, and z. Right? So I'm going to need all three of those to answer the question. So none of them are given, but with a little bit of math, okay, it doesn't make sense that if this car drives for 2 hours and he's going 60 miles per hour, that at the moment in time we're interested in is when that driver has gone 120 miles. All right, and for Y, driving 50 miles per hour after 2 hours, that driver has made it 100 miles. Okay, and at this point, if you've done a few of these, you might recognize you're going to need Z. Okay, but if you don't recognize that, we can find it later. But in this moment in time, we have at 2 hours is the moment in time we're interested in. X squared plus y squared equals z squared, and that means 120 squared plus 100 squared equals z squared. Take the square root, and if I plug that into my calculator, I should get 156.205 miles. Okay, so when x is 120 and y is 100, the distance between the two cars directly would be 156.205. All right, so now we're finally ready to do the calculus. Take the derivative of this guy with respect to time. Chain rule, 2x dx dt. All right, and they're all the same thing. They're functions of time, so we're going to treat them the same way when we take the derivative. 2y dy dt plus equals 2z dz dt. All right, and then my final step would be to solve for the unknown, or solve what we're trying to solve for, what the question asks about, and that, of course, would be this, dz dt, the rate at which the distance between the two cars is changing. That means, and that this works for all of these related rates problem, that means I need to have a value for x, y, z, dx dt and dy dt. If I want to solve for dz dt, right, I need all the variables here to be known for this particular moment in time in order to find dz dt. Okay, and we should have all those. So I'm going to go ahead and plug everything in. If you want, you can recognize if you divide both sides of the equation by 2, these guys will go away. And then I'll solve for dz dt by plugging in my values. X is 120. Dx dt is 60 miles an hour. Y is 100. Dy dt is 50 miles per hour. Z we had find. dz dt. And now I'm on to my calculator. Basically, I'm going to divide both sides by this value. And get my solution of, plug that into my calculator, I get 78, and I'll round to 1 decimal place, 78 miles per hour. Okay, and we could state our answer, taking the wording from the question. The distance between the two cars is changing at a rate of 78.1 miles per hour.